It's my pleasure to welcome the Chief Technology Officer of Rakuten Symphony, Raghunath Hariharan. Welcome, Raghu. Thank you very much for joining me. Thank you. So, Raghu, to kick things off, maybe you could give us your take on the current state of play with 5G. Has 5G delivered the outcomes we expected? And what's your take on where things currently stand?
First of all, thanks for having me. This is very exciting. We are in MWC, one of the biggest conferences, trade shows in telecom. So let me start off by talking about a couple of inflection points. 2007 was an inflection point where we saw the transition of a voice-centric network to data-centric networks. The second inflection point was in 2020, when we saw legacy RAN changing from a very proprietary based solution to a virtualized RAN and evolving into open RAN. A couple of years I predicted that 2024 will be the year where AI RAN will ramp up, and we'll see a lot of AI in RAN. And I think 2025 is the time when we will see the advent of 5G advanced kicking off. And with that as the basis, maybe I'll answer your question about 5G. The unprecedented success that 4G received and the growth that we saw in 4G was unfortunately not that received in 5G. I think 5G had too many promises that it did not deliver. At the same time, we are now seeing 5G advanced coming in, and we are seeing in 2025 an inflection point where we are going to see a transition from a human-centric technology or an adoption which is very human-centric into something that I predict to be very machine-centric. And with that, there is going to be an order of magnitude growth in devices that are going to be very sensitive to latency. They are going to be very sensitive to committed information rate, predictable SLAs, and that is going to drive the next era of wireless communication growth in 5G advanced and 6G.
See, it's an interesting concept you've touched upon there, the shift from human-centric to machine-centric. I know that's an idea that's sort of close to your heart, as it were, but that's a concept that may not be as familiar, or our audience may not be as familiar with. If you could just take a moment to explain exactly what you mean by that shift from human-centric to machine-centric.
Sure. What I mean is basically if you look at 4G and if you look at early 5G, a lot of the smartphones, a lot of the devices, even wearables, are requiring human intervention. So the smartphones are used by humans. Basically, they are used for various types of applications. And humans are tolerant of certain spikes in latency. They are tolerant to certain SLAs not being met when throughput is poor. And they normally shift over to Wi-Fi when cellular coverage is not so good. But machines are not going to be so tolerant. They are going to require deterministic latency. They are going to require deterministic throughput. They're going to require deterministic service level agreements, which will drive these machines. And these machines are not going to have human intervention. They are going to be in the form of various devices, from your home to your office to your vehicles. There are onboard computers. They're going to take actions autonomously. And in order for all these autonomous decisions to work flawlessly, you need deterministic scheduling. You need not very high throughput, but you need a deterministic throughput. And those are going to be the driving factors for 5G advanced and 6G.
So in a nutshell, things have to be precise, they have to be clearly defined, or mistakes will result. Is that fair to say?
Yes, definitely. Especially if you look at autonomous vehicles. Let's say we want to reach that objective of level 4 autonomous driving. These decisions are going to be made in millisecond or sub-millisecond granularity. There cannot be mistakes. Yeah. And some of this is going to be driven in coordination with the network. So precise is very important as we move forward.
Absolutely. I suppose that sort of begs the question, really, going back to the first point slightly, is really, is it the best option at the moment for mobile network operators to optimize what they have in terms of 5G with software? Or is it worth making that transition to 6G at this point in time if we are truly to get the best out of that machine-centric shift that you're talking about?
It has to be a transition. We have to go through 5G advanced. We have to adopt some of these new methods of developing algorithms, which are going to allow us to learn, how to really adopt AI in the RAN. How do we do network shaping or network slicing? How do you do traffic shaping? How do you do traffic policing? How do you make sure that you deliver to the deterministic latency and throughput goals of 5G advanced? And that will result into what we can go into 6G, where now you can talk about applying AI to the physical layer, using different types of waveforms at the physical layer depending upon the channel conditions. And that is a stepping stone. It's a learning step. We cannot avoid going through that step. Just like we had to go through certain steps when we evolved from a very voice-centric network to a data-centric network. Something that we had to learn when we went from, specialized DSPs and ASICs to general purpose processors in VRAN. Similarly, the transition from a human-centric network to a machine-centric network will also have to evolve. It will have to go through these phases. And so we cannot just jump into 6G directly.
If you had to roughly put a time frame on this transition, I know that's a bit of a vague question, but is this going to be a very gradual thing? Is this something we're going to see a sharp rise in with the rise of AI? How gradual is that transition from human-centric to machine-centric going to be?
It's going to be clearly demarked by two points in time. 2027 will be the adoption of 5G advanced, and we will see early deployments in 2026 and so on. And we're going to see technology development this year. And 6G will be more like a 2030 technology.
Yeah. I mean, that's obviously based on, I suppose, timelines based on the telecom industry, but obviously the enterprise is moving at an incredibly fast pace. Is that likely to throw things off kilter based on that?
So what we are going to do with the private 5G is happening now. Yeah. There is already a need to bring in mobility into the enterprise and tie it in with Wi-Fi. So we are going to see that convergence happen as well. So some of that transformation is happening as we speak.
In terms of that, again, we talked about transitioning to 6G, but how can operators actually get ROI on that investment? How is that going to be any different from 5G, and what are going to be the biggest differences in that sense?
So that's where I feel that, and we should use Rakuten as our prime example. I mean, if there is any doubt in anybody's mind that this is the way to build and operationalize and densify networks, there should be no question about it now, because we are a network. Over the last 6 years, we have more than 8.5 million subscribers. We have more than 400,000 cells. And Rakuten is a prime example of how do you really operationalize and monetize that network because of the several different services that we offer on top of our wireless network. So other wireless providers should adopt the same policy where there is content. And now, by providing these differentiated services is another way to monetize the technologies that are coming forth.
I suppose an easy question might be then, and many operators would have this question, is say they don't have the similar kind of ecosystem that Rakuten has. What can they do to kind of optimize those opportunities?
There will be collaboration with content providers. Yeah. We can already see some of the operators working closely with content providers. And second is, being able to monetize specific services, which comes from network slicing, which comes from adopting technologies that can provide these differentiated services. So I think that's where the monetization opportunities would arise.
Excellent. Thank you very much. We've talked about AI. Let's give some specific examples or your take on the ways in which AI can optimize things such as the RAN, OSS, and general automation principles, I suppose. Can you think of any immediate examples that come to mind in terms of how AI can really, especially, I suppose RAN is maybe your best area of expertise. Are there any examples that come to mind there in that sense?
So before I answer that question, I think there are so many opinions about AI, and I have my own. So there are at least 3 different dimensions in which AI is going to help all of us. The first dimension is to improve human efficiencies or human productivity efficiencies. And that we are seeing already, we are adopting that today with the co-pilots and the chat GPTs and all of that. It's improving human productivities and in efficiency in that dimension. The second is the computational efficiency. And that's where we see some of the accelerated computing, helping us realize or render some of the algorithms much faster. I mean, near real-time efficiencies through some of the GPUs and other accelerated computing devices that we are seeing. And the third efficiency, and that's my primary focus, is to take those 2 efficiencies and build that into our product. How do you really leverage AI in your product? How do you improve product efficiencies? And that should be core for any company. They're trying to improve the efficiencies in their core offering. And we are doing several different steps in bringing AI into our RAN product offering that differentiates us with our competition. Several things include some of the things that I mentioned about being able to use AI to realize deterministic latency, traffic shaping, traffic policing, to use AI to be able to predict location of a specific device very accurately, to be able to use AI to, if I take it to the other extent, I have members in my team who are working on a digital twin. And digital twin is something that is being actively pursued. It was pursued in the past as well, but you can now use a digital twin to drop your software, be able to realize a complete drive test simulation, synthesized result from your digital twin, and then be able to push software loads directly into the network. So those are some of the more advanced AI techniques that we are trying to apply to improve product efficiencies, but some of the other incremental steps are also in place to improve our product offering.
What does that journey look like, though, in terms of adopting those incremental steps? I mean, is it a question of onboarding the right skills? Is it a question of changing your processes? What are your thoughts on those areas?
So it is. So first step would be to be able to reskill. We have exceptional talent in our company, but some of these techniques and underlying infrastructure is new to a lot of us. So to be able to leverage, how do you actually use accelerated computing? How do you really benefit from making sure that your synthetic models or your actual empirical data that you're feeding into your models are valid? How do you verify the accuracy? How do you verify that the inference is actually generating a proper, accurate output and not a hallucination? So there is a little bit of skilling that has to go through. At the same time, we have the core experience and expertise from building wireless networks for 2 decades. We know how these networks behave. So when we look at the results, that's where the human knowledge comes in. And that's the augmentation which happens with the machines. That the machines are able to do things faster and more accurately, and there's no question about that. But at the same time, to be able to interpret some of those results with human knowledge is very important. And some of those, the RF planning and some of the RF related things that we have built over 2 decades, that helps us build better algorithms together with the AI and machine learning algorithms.
So is it fair to say, I suppose, domain expertise plus the use of AI is something that's really going to hold the key, perhaps, in that sense?
That's how it's going to be.
Yeah, absolutely. You've touched upon the importance of the infrastructure there. I know that a topic that you're keen to discuss is GPU usage versus non-GPU usage. What are your thoughts on the economics of that at this point in time? Is there going to be an inflection point there in that sense? And is Telecom ready for that kind of shift in that sense?
So that's a very tricky question.
Yep.
So today, if I see the adoption of GPU to accelerate certain types of algorithms is a given. We have to do that. Now, whether the GPU can be put at the cell site or it has to be centralized in a data center, that TCO analysis is an ongoing effort, and we have to see, how that can be built out into the networks of tomorrow, and whether that will be the way we will build out 5G advanced. The handle that we're trying to see is, okay, some of these GPUs are humongous. And even if you aggregate a large cluster of cells in a central data center or a regional data center, there's obviously going to be spare capacity in those GPUs. Can we use that to run different other types of algorithms? So that's something that's ongoing, and that will shape up in the next 2 quarters.
Yeah.
That's what we are doing right now.
And perhaps even beyond then, I would imagine as well. It's a question of time will tell. Perhaps a lot of analysis is needed in that area. I know you wanted to sort of also discuss the balance of, well, obviously we've talked about human-centric versus machine-centric, but also the ways that AI will affect telecom more broadly, and where that leaves people with traditional telecom skills perhaps. How is that relationship going to work, and where do you see the role for, well, employees versus the use of AI?
So I think one thought comes to mind immediately. I think John Chambers once said it, and I believe in that, is change or perish. The dawn of AI has happened with ChatGPT and some of the newer techniques that we are seeing with agentic AI and some of the things that Jensen Huang has talked about. AI is here, and AI is here to stay. So it's time for us to accept that and use it to our advantage, to build better systems, to build better algorithms, and get results that, for example, in my past, when we used to do system-level simulations, we had a complete framework that we would synthesize 10 milliseconds of airtime, and to generate the network with the first order interferer and the second order interferer, just to generate the network, not to produce results, would take 48 hours. And then you ran the actual simulation that you wanted to run, and that would take some more time. And then you had to run it several iterations to get a result that you could say that this algorithm meets its objective function. Okay. The whole process was very inefficient, but that was what we used to do, and a lot of telecom engineers used to do. I mean, some of them still do. But if you now take a GPU and you try to train and build a digital twin of that same network that you want to simulate, and you want to run an objective function, you can generate results pretty much in real time. 10 milliseconds can be result. You can produce a result of that 10 milliseconds of airtime in real time. And you can run several hundreds of iterations and produce a result that you think that, okay, this makes sense, and it definitely helps you build your solution in a much more efficient way. So I feel that adoption is imminent. I mean, we have to do it. And that's the way we are going to build the networks of the future.
Excellent. Thank you very much. Ladies and gentlemen, please put your hands together for Raghunath Hariharan, Raghu, the Chief Technology Officer of Rakuten Symphony.